All right, everyone. Very good morning. Very good evening. Let's get started with this today's demo session. Hope you can hear my voice. Uh, if any challenges, just ping here in the chat or can just let me know. Okay. Thanks, Satvik, for confirmation. Uh, right. Let's get started now. Again, same thing. While explanation, if you have any questions, queries, feel free to unmute yourself and ask here, or you can use this chat window and you can post your any questions or queries. Uh, and then yesterday we covered a couple of things. We started with the introduction about uh, me, and then we started with the course curriculum, right? So we started with the understanding course curriculum and the fee structure and course duration and what is the importance of this course, right? So and then we started with the uh, architecture, like basic architecture of my database, and after that we started with the couple of things on the standalone versus rack, right? So these are the 4 5 topics we discussed yesterday. So today we'll continue and we'll start with the further more discussion on the same architecture and the networking part. So I'll just give 1 or 2 minutes to anyone to ask any questions if you have it, based on my yesterday session or any further more queries to that or questions, feel free to ask, or else I can get started with this today's session if there's no questions on my yesterday's topic. It may be course related or it may be um, your payment related or course duration or whatever it is, right? If anyone has, like, just feel free to unmute yourself and ask. If not, then I'll take it as a no and then I'll continue. All right. So uh, we understood yesterday the 3-tier architecture, right? So basically any organization, let me open that slide and then let's go here. Let's search it. Okay, let me get that slide and then we can discuss that one. Give me 1 more minute. Okay, there it is. Right. So any organization, we talked about this one, right? So this is our DBA part here. So when it comes to the backend layer, data management layer, that is where we are going to install our databases, and DBA we are going to manage our backend layer. The front end and the middleware or the middle tier or application tier, this doesn't matter. So it will not come under DBA scope. So at the back end, whatever the server where we install our databases, we are going to manage those machines and those databases which we installed over here. So that's what we're going to talk about now. In that, we understood this particular database server or the Linux server. So pretty much comes with these 3 major components, right? What we talked yesterday. It comes with the memory, it comes with the processor, the processes, and it comes with the backend um, data files. So these are the 3 major components for any database architecture: memory, background process, plus backend data files. These are the 3 main components of my database architecture. And in that memory, if you talk about, we have so many components inside that. So I'll just write it down here so that, so the main architecture part comes with three main component, right? One is instance. So that instance is nothing but memory plus background process. And the second one is your backend data files or storage files, right? So I can say three main component or database architecture. So these are the two main components for my database architecture. Let's put it down here. So anyone ask you to explain about database architecture, my database architecture mainly depends upon two main component. One is instance and the backend storage. So instance is a combination of your memory plus background processes, and the storage files are the backend storage or the data files are the actual data files where end user data is going to reside. Right? These are the two main component what we discussed, instance plus the storage files are the database. In this instance, come to memory part. So in this memory, we have so many components, like, I can say.
Hello, sorry to interrupt.
Yep.
So did you share the screen?
Yep, I shared the screen. I hope everyone can see my screen.
Yes, it's visible.
Yeah. All right. Let's check your Zoom settings. Right. So this memory has many component. Right. This memory has a many component. I'll just brief it over here. What are those memory component? So just few of them I'm giving it over here as example. Your SAID pool is one of the memory component. Your Java pool is one of the memory component. Stream pool is one of your memory component. And your large pool is one of the memory component. Your database buffer cache is one of the memory component. And redo log buffer cache is one of the memory component. This is few of them, main memory component I'm listed out here. Along with that, there's other more memory component, right? So this is my main memory architecture. So if somebody asked you to explain about database memory architecture, so memory architecture mainly comes with the two main memory processes or the memory segments. One is, I'll just give a brief idea, PGA, and other one is HGA, right? So memory component, there are many components inside that, but two major memory segment is your PGA and HGA. HGA, again, it has many sub component inside that. And then PGA, again, it has many sub component inside that. But we never, explain about PGA part when it comes to architecture, because the PGA stands for private global area or the program global area. HGA stands for system global area or shared global area. What are these two memory component? How these two memory component different? And then I know this SGA comes into picture. Inside my instance, I can see my HGA component here. And when this PGA will come, like when I explained yesterday this architecture part here, right? We talked about only this one. We talked about only one memory component here. Like, we talked about this component, which is inside my instance. And this is nothing but your HGA. And then these are nothing but these are my background processes. So where is my PGA then? So I talked about memory is nothing but HGA plus PGA. And then what is this PGA? Where this PGA comes into picture? That PGA comes into picture. We talked about this one, right? So these are my actual data files, which will be resides on my storage here. Right? These are my data files. And then I have my database instance here. And then this database instance is combination of SGA. I can say here SGA. Give me a second, guys. Sorry for that. Okay. This is my database or the storage files, or I can say backend storage. You can call it as anything. This is your actual data files, or the actual physical files are going to reside in your OS or the NFS or SAN or NAS or whatever the storage you use, right? And then this is your instance. And then in instance, we talked about this is your BG process, or you can say just processes, background process or processes. You can just say whatever you feel like. These are like your processes, right? And then this is your memory. We talked about this is your memory. So this memory is nothing but within inside you have memory SGA. So again, this memory component has many more subcomponent, right? And then we talked about if any client comes, right? Client 1, client 2, client 3. I can just say my client 1, my client 2, and client 3. All these three client comes, they don't have direct access to my database server, right? They don't have access to my database server. They have to connect to first my database instance. Through that instance, they'll not talk to my database. And if they're selecting the data, they will read the data from the data files, and then the result will be like they're gonna connect to my instance first from the to the memory. From the memory, they're gonna talk to my or read my data files, and they will get the data back from the memory again. They will get the back. So if it is a select query, if he's inserting the data, he's gonna write the data into my memory. From the memory, data is written back to my data files. So if it's a returning, and if it's selecting, the data will be given back. If it's writing, just data is gonna write it to my data files. So we have only SGA memory comes into picture, but where is the PGA? So we talked if this client 1 is doing some select on employee table. There's a table, employee table, which has hundreds, thousands, millions of rows, and that table is sitting here in this particular data file. If he is reading that select employee table, his session first comes to my memory, that is SGA, and from that SGA, it's gonna connect to my data files, backend storage, and then it's gonna read that particular employee table, and then it'll give it back to memory. From the memory, it'll give it back to that user, right? That will give it back to that user. So in order to establish this client connection to my database instance, first thing, and from that database instance, it has to read the data from the data file. So for this, on behalf of client, there should be one process has to do all this task. Go your query, search your data, and then get your result back. So there should be one process to act on behalf of this client. That we talked server process, SP. So the moment this client connect to my database instance, one process will be started for him. That is called server process. That server process will read the data and then give it back to that client, right? So this server process to run, this server process to operate, it needs a memory. Whatever this background process here you are seeing, in order to run this background process, you have this SGA memory component. This memory component helps this background process to run. But this server process, which is started on behalf of this client, in order to run this server process, it needs some memory. Where is that memory? That memory will be called as a PGA, right? Each of every client, if I have 1,000 clients, and then 1,000 server process will be started, and all these 1,000 server process and 1,000 PGA memory will be allocated to them. So that's before coming to your database instance, right? Before coming to your database instance, all these things will happen. Your server process will get started for all those end user clients. And in order to run those server process, you need a memory structure. That memory structure is called PGA. That is private global area or program global area. Why that is private? Because if there's 1,000 user process, 1,000 client connections, there's 1,000 server process will be started. In order to handle those all 1,000 server process, there's 1,000 PGA memory will be allocated, like one-to-one mapping, right? One client has one PGA. This client 2 has its own PGA, and then he has its own server process attached to it. That's your client 2. And then client 3 also has the same server process, and then he has its own PGA memory structure, and then that's going to connect to my database instance. So the PGA stands for private global area or program global area. Private means it's like user 3, he has its own PGA. This PGA cannot be used for user 2 or user 1. That's why its name stands for private, one-to-one mapping. Whereas this SGA, we can call it as a system global area or shared global area. This client 1, client 2, client 3, all these 3 has their own PGA, but they all going to work on same SGA. That's where SGA stands for shared global area. One SGA or like hundreds of PGAs, right? That's two main memory component, SGA and PGA. Within SGA, there are so many sub memory component. Within PGA, there are so many sub memory component. We're going to talk about that, what are these memory component and all those things during our actual course. But for now, what you need to understand, whenever somebody asked you to explain about database architecture, so database architecture mainly starts with instance plus background process. And then this instance is nothing but combination of memory plus background process. This memory is nothing but it has a combination of your PGA and SGA. Again, PGA has so many subcomponent and SGA has so many subcomponent. If I can just quickly show you that those components, right? So these are the things. So your SGA, this is your SGA memory, shared memory. It has these many subcomponent. And if I can go further, your PGA, again, PGA has there so many subcomponent. And one client connection comes, one PGA, one server process, and second client connection comes, second PGA, second client connection, but there's only one HGA will be like shared across all. Sorry guys, okay. That is your memory structure. When it comes to database architecture, so this is what you need to explain. So database architecture mainly combination of two main component, instance plus background process. The instance is nothing but memory plus your database architecture is basically combination of instance plus your actual database or the data files. And in that instance, we have two major component called memory structure plus background processes. In that memory structure, I can say, let's go with here, like, your memory is combination of HGA plus a PGA. So your memory is a combination of HGA and PGA, and HGA stands for system global area or shared global area. PGA stands for program global area or private global area. Again, each of this SGA and PGA has several subcomponent, and your SGA has shared pool, large pool, Java pool, and DB buffer cache, log buffer cache, all those things. And again, your PGA has so many subcomponent, your memory stack and stack space and all those things. Right? That's your memory structure. And then second one, in that instance, the first thing is your memory structure, right? And then the second part for your instance is your background processes. Background processes, or you can just say processes. Right. So this background process, again, there are several background processes. Right. If I can go back here. So these are the few of them. Your checkpointer, SMON, PMON, DB writer, log writer, recoverer, and archiver. So this is for the standalone. If you talk about ASM, again, there are few more background processes will get added here, right? You can see these are the few more background processes: ASMMB, RBAL, and your OHAS, CSST, disk mount, Aura agent, Aura root agent, and CSAT agent. So when you talk about grid infrastructure, there are few more background processes will get added. And if you talk about without ASM, just a standalone file system, these are the mandatory background processes, right? So these are the core processes which will run when you start your um, database instance, right? These are your memory structure and the background process. Again, this each memory structure has its own unique work, and each of these background process has its own unique work. For example, we talked about any data read or write, it's going to read and write to my memory structure. So your database buffer cache is the one which is going to handle that reads and writes. And then once your data return to your database buffer cache, from that buffer cache, it's going to write into your data files. That will be done by your DB writer background process. So again, we'll talk in details. What are these background process? Why they will do? What activity they will do? When during our regular classes. In simple words, checkpointer is going to update your control file and data file header, and pmon is going to responsible for your instance recovery or crash recovery, and smon, and pmon is responsible for handling all the end user connections. If the any sessions or any user session is terminated or went into idle session, whatever the resource it is held by that session, the resource release and lock release, everything will be handled by your pmon. And db writer is going to write from the memory buffer cache to your data files, and your log writer lgw are going to handle the writing operation of your redo log buffer cache to your redo log files. And then uh, your recovery is going to responsible for handling your distributed transactions. Whatever the in-out transactions, your recovery will handle. Archiver process is the one which is going to generate your archive redo log from your online redo log files. Again, we'll discuss all of them in details when we start our regular class. But in simple one-word sentence, these are your background process and then why they're used. And coming back to your memory structure, shared pool, which is responsible for handling your data dictionary cache and the library cache, whether there's any execution plan is already available, and the parsing, and whether the syntax is correct, semantic checks, all those things will be handled in your shared pool. And Java pool will be especially used for whenever your database is connected with the Java applications. If your application is made up of Java JVM virtual machine, so Java application will be used. Stream pool will be used for your Oracle streaming, and that's again we'll talk in more details. If there's a concept called Oracle streaming, table to table level replication, the stream pool will be used. And large pool will be used for your IO operations. For example, when you do RMAN backups, restore recoveries, and your data load, your large pool memory segment will be used. And database buffer cache, any client, any user like this client one, client two, client three, they will read and write from memory structure, so that your buffer cache. If this client one is inserting some record, he's going to insert into my database buffer cache. If the client is reading some record, they're going to read the data from here. Again, it'll come back and write into memory. That's going to write into your buffer cache. From buffer cache, it's going to give it back to that client. So that's a major memory component in my database, buffer cache. Any reads and write happens to my buffer cache first. From the buffer cache, it's going to go to my data files. Or from the data file, it's going to go back to your buffer cache. And whatever the transactions you happen at your database buffer cache, the transaction logs, the redo vectors or the change vectors will be written to your redo log buffer cache. Right? Based upon this memory structure, so the respective background process will align or act. Right. That's your overall instance level, right? So your memory structure plus background process. Memory structure SG and PJ. Again, in the SG and PJ, there are so many sub memory component, and in the background process, there are so many sub background processes, and especially when it is standalone and there's a grid or the ASM. We call it as a standalone, or we call it as a ASM or grid. So based upon your standalone, you have some background process. right? And then based upon, I can just put it over here so that. So based upon your standalone database, you have many BG processes. And then you have your ASM or grid. Again, you'll get some more background process. And then somebody asked in the chat here, what is standalone and what is grid? So if you install your database on a single server in the file system, that's a standalone. If you install your database on ASM, automatic storage management, this is provided by Oracle. If you install your database on ASM, that's called grid or the ASM. So based upon what kind of database you install, whether you installed on the server or whether you installed on ASM, your background process are varies. So I can show you here one demo. So I have my, this is my Oracle Lab 1. I can make it simpler, like this is my Oracle Lab 1. So Oracle Lab 1 is your server where I have a standalone database. And then I have this Oracle Lab 2 server here, and where I have my ASM. But I can just put it over here so that it'll make more sense. Right. So this is my standalone server, standalone database running under Oracle and running under file system. And this is my ASM. So how I can verify? The simple command, the moment you do ps-ef grep smon, this is the command. The moment you run this ps-ef grep smon again, this is one of the background process, right? In my slide here, right? You can see smon is one of your background process. The moment you run your smon, you're going to say that, okay, what all databases are running here? ps-ef grep smon, I can see devdb is my database. For that, I have this smon background process. And the same command ps-ef grep smon, if I run it on this lab 2 here, I have devdb database, one smon for that. And I have a test cdb database, I have one smon for that. Along with my devdb and testdb, I have one plus ASM. So which indicates you have your ASM installation here. So whenever you see this plus ASM, that indicates your database is running under ASM. Right? That's where you need to identify whether your database is standalone running on file system, whether your database again standalone database running on your ASM. Both are standalone, single node, single server, single database running, and where it is running, whether it's running on whether it's running on your file system or whether it's running on your ASM. That you need to understand by just running ps-ef grep smon. The moment you see this one, okay, these databases are running on ASM. And other way to verify is connect your database. I'm going to connect to my database on my Oracle Lab 1. I'm going to connect to my devdb SQL plus /sdba. So the moment I do select file underscore name from db underscore data underscore files. So the moment I do this one, select file underscore name, and you can see all my data files are here. You can just exit from here. And if I can go into this location and let's put it over here. Right. So if I can go to this location, CD, go to this location here and do ls-ltrh. So you can see all those files, temp, system, sysocs, undo, whatever you listed out in your database, system, sysocs, undo, all those files are available in your file system, in your server file system. You're gonna see it over there, right? That is your file system, your database standalone. Standalone means single node database running under your file system, OS file system. It may be SAN, NFS, NAS, or local file system, whatever it is. That's your standalone database on file system. Again, standalone database on ASM or grid. I can go to my Oracle Lab 2 now. I can set this environment here now. Or I can go to this database or this database, any database. Let's take this database now. .orinv. SQL plus /sysdba, and then I'll run the same command. Select file name from db underscore data files. If I run this one, and you can observe here your file system, your file user, undo, system, sysux, all these files are starting with this plus data. Your ASM also started with your plus, and all your location are started with your plus data. So whenever you see this plus symbol starting with that, that indicates your ASM storage. Storage is provided by ASM, Automatic Storage Management. It is provided by Oracle. So if I can try to CD here, you'll not be able to go. This is not a file system. This is not your storage. That is your ASM storage. If you try to do CD plus this one, you'll not be able to go there. So there's a different way to manage this file system. So for that, I need to set the environment to ASM .orinv plus ASM, and then there's a command line utility called asmcmd. The moment you run this one, asm command line, it will gonna go into your asm command line. Now you can do cd that particular file system, and if you do ls-ltr, you can see all the files whatever you see at your database side. So that's the only difference, whether your database is standalone or not. How you can identify? Just by running ps-ef grep smon, you can see your database is running on one server. And here also, if you do the same PSF and you have grep smon, your database is running under one server. But whether that database is running under file system or whether the database is running under ASM, file system is your local storage provided by your OS admin or your Linux admin or your NFS, SAN, NAS. The file system may be coming from anywhere. So just go to that database. For example, in this lab one, I went into my database. I just ran that select file name from db underscore data files. It's going to give me starting with the slash. That indicates it's a file system database. Your database is running under file system. So you can go to that file system location, cd, that location, and you can see all the data files. And the same thing for your ASM, if your database is running under ASM, Automatic Storage Management. Again, same thing, set the environment to the database, connect to the database, and run that select file name from db underscore data files. You're going to get all the data files for that database, and that start with a plus that indicates it's a ASM storage. So that's how you can validate whether your database is running under file system or ASM. Based upon those file system and database, your background process will get vary. How? You can validate here. ps-ef grep devdb. Right. So I'm just gonna do ps-ef grep devdb. Sorry. Devdb. And I can see a lot of background process here, right? So, but I listed out only few of them here, right? Checkpoint, smon, pmon, dbrater, logrator. If I can go here, logrator, dbrater, and pmon, and go further, and where is the smon, like all this, whatever I listed out here, the mandatory background process, all you can see. Along with that, there are so many other background processes as well. And if I can do count of this wc-l, how many are there? And you can see 61 background process for that one single DevDB database. And I'll go to Oracle Lab 2 here, and ps-ef grep smon. I can check for my test CDB, ps-ef grep test CDB. And again, there are so many background processes for here. And if I can, again, like if you can list it out, what are those background processes? Most of them are like same thing, smon, logrator, dbrater, and your pmon, all those things. So then if I can count those wc-l, I'm going to count those, and you can see 87 here. So in your normal file system database, just 61, and in your ASM, it become 87. Why? As I told here, your database is running under file system. It has bunch of background processes. That's called standalone file system database. And if your database is running under your ASM, again, ASM also has so many background processes. So that's gonna get added here. This is like combination of your ASM background process plus your database background process. Altogether, it become 87 over here, right? So that's where you need to deal with all these background processes when you are working on which environment, whether it is a standalone database with a file system or standalone database with a ASM. Right. So for that, these are the example here. Few of the example, like these are the background process for your standalone database with the file system. And along with these background processes, you get some more background process when you use ASM. And then along with these are again background processes related to ASM. So along with this file system database background process, these are the background process will get added to your list of background processes. Right. So that's for your uh, instance wise memory and the background process, how we're going to explain and how we're going to understand. Right. Any questions so far here? I can say a couple of questions here. What is TSM? TSM, again, what is the full form? If you can give, I can explain you. TSM is one of the storage vendor, one of the backup vendor. If you can give me the full form of the TSM, because the full form is varies from varies. So what I can think of TSM is backup and recovery solution by third party vendor. And what's the minimum configuration for PGA and SGA? Again, that PGA and SGA, whatever we talked about this PGA and SGA, that is left to you. While creation of your database instance, you are going to define how much PGA and how much SGA. You are going to define it while creating your database. I can control that one. I can give PGA 1 GB, I can give SGA 2 GB. I can give 10 GB PGA, I can give 20 GB SGA. I can give 50 GB PGA, I can give 100 GB SGA. It is left to you how critical your database, and you can define all of them.
Sir, I have a question.
Yep.
What's the difference between PGA and SGA?
I just talked about, right? A PGA stands for
I just logged in.
Yeah, it's
Sorry,
I
I was
already
late.
explained that one. You can just revisit this video, you can understand. PGA in short form, program global area. It is individual to end users. SGA is for shared global area. I explained I already on this one. You can revisit this video, you'll understand. Right.
Okay, thank you.
All right. And then there's one more question in the chat. Okay, please go ahead.
Yeah, sorry. Yeah, I just joined the meeting. Sorry, I didn't
Sorry.
know.
Yeah, you can revisit this video. You can understand
Right.
more on that. Already I explained on that. Yeah, please go ahead.
Okay,
Anyone
thank
has any questions? All right.
The
Sir,
PG
this
separate software.
What is that?
PGA is a separate software.
There's no software here, right? These
Okay.
all your memory allocation. There's nothing called this instance is not a software. And this is not a software. This is the architecture. When you create your database, how your database works.
Okay.
Right. There's nothing, this is not a software, this is the architecture, how it works. I'm not, it's like an installation of your database. Once you install it, this is how all the components are interconnected inside your database. Right. There's one more question in the chart. What's the difference between ASM and grid? Yeah, again, your ASM, grid, and rack, they are like correlated one. So we are not going to talk about rack. Your ASM or grid are one and same. You can call it as ASM or grid. Both are same.
Hi,
Yep.
how the backups are managed in ASM?
ASM is not a database. It's just a mediator. There's nothing called data files or nothing on that. So it's
Yeah,
just
in
like
the
process.
standalone backup, we are storing in file system.
Anywhere, like you can store it anywhere you want it, your backups.
Okay.
Whether it's a file system or whether it's a tape or whether it's a ASM or wherever you want, you can just store your backups. No restriction on that.
Okay, thanks.
Right. Right. So that's your main understanding, a memory plus background process. Anyone ask you to explain about database architecture? My database architecture is mainly consist of instance plus backend data files. Again, my instance is the combination of memory plus background process. And in the memory, I have SGA and PGA. PGA stands for private global area or program global area. It is one-to-one mapping. If 100 sessions comes, 100 PGA will be allocated. And SGA stands for system global area and shared global area. It's a shared between all those 100 or 1000 end user connections. And coming to my background process, there are so many background processes. These background process are varies based upon your database type, whether your database is a file system or whether your database is running under ASM. And with that, you can have a lot of background processes. Few of the mandatory background processes are your PMON, SPON, checkpoint, debrider, logrator, archiver, recoverer, all those things. And coming to second part of the architecture, that is the backend data files. You have so many data files here, so many things, or backend data files, or you can say your storage files. Some people will say, what are your backend data files or storage data files or database files, right? So that's your second part of your architecture. But if I can go back here, I'm talking about the second part of this architecture here. So we talked about this memory and the background processes. Now coming back to this data files or the storage files, there are so many things here. The first and foremost thing is SP file or P file. And the second thing is your control file. And the third thing is your data files. And the fourth thing is your, I listed out here, like if I can try listing it over, there's so many things. If I can come over here, right here, your SP file, P file, control file, data files, online read log files, right? And then you have archive log files. And then you have your password file, and then you have your alert log file, and then you have your trace files, and then you have your backup files. There are so many things. When you talk about the backend, there are so many files that keep on list is keep on going, right? Your control file, data files, online read log files, archive log files, trace files, alert log files, your backup files, and you can again you have a few more, add it up, undo and temp files. So this list is keep on going, right? So that is all together is your backend storage for your database, right? So you can add to the list. So that's your, and again, each of these files has its own task, and each of these files are play very, very critical roles when your database is running, when your database you are starting it out. So you have to understand, again, we'll explain why I need a SP file, why I need a P file, what's the importance of that, what's the difference between SP file and P file, what is a control file, what happens if I don't have a control file, why I need a control file for my database, and why I need a data files, why I need this read log files, why I need archive log files, what is the use of my password file, without password file, can I run my database? All these things we'll explain furthermore when we start our actual classes, right? And then few of the things, if I want to show in my database for these files, whatever I talked, I'll just connect, select name from $, control file. So I have my control file 1, control file 2, and select name from $, log file. I have my, so select member from $, log file. So I have read log files. There are 6 read log files. Again, these are commands right now you may be having difficulties, but once we start the course, we'll understand what this command, why I'm running this. But I'm just going to show you now your read log files ending with log, your control file ending with your .ctl. Select name from $, data file, right? So these are your data files, right? Ending with .dbf. Right. Similarly, you have your SP file, password file, and your backup files, archive log files, all those things you're going to see it in any of the database. Right. That's a simple understanding of your database architecture. What are those main component and how it works. In simple words, your database architecture start with instance plus background, instance plus data files. The instance is memory plus background process. The memory is SGA and PGA, and background process. There are so many background process: checkpoint, debrider, logrator, archiver, recover, and all. And at the backend database or backend storage, I have data files, control file, read log files, archive log files, password file, SP file and P file, trace files and alert log files, undo files, temp files. All those things are your actual data files. If you try to explain this much, that's more than enough. you can, answer to that, the common questions. Most of the interview, that's a common questions. Can you explain about database architecture? So you should be able to explain about this, right? So in simple words, this is your overall architecture. How it works, like, client one connect to your database, and the moment he connect to my database instance, he cannot connect to my data files, right? Actual storage. He has to connect to my instance. The client one, he will connect to my instance, right? Instance is a memory plus background process, right? And then this client, whatever connected, the moment he connect, he will be allocated with the server process to him, and the memory will be allocated to him. That's a PGA, one-to-one mapping. And then he will connect to my instance. And then if he reading the data, so actual data is here in my data file, and this server process, you can see this server process. If he is reading the data, and he will give that request to my instance. So from that buffer cache, the server process will go to that data files, and then it's going to fetch that data which is available in my data files, and then it's going to keep it in my buffer cache. From the buffer cache, and then it will give it back to that user, right? That's a read operation. Your server process will take care of that reading your data and then giving it back to that user. Again, client 2 comes, right? So the client 2 will be having its own server process will be started, and for that server process, the PJ will be allocated for him. And then he will be connecting to my database instance. He is inserting the record. He's not reading, inserting some record. From employee table, he's inserting one employee details. And the moment he insert that record, the server process will write into buffer memory here, buffer cache. Right, reading was here, and the same buffer cache will going to write that entry, whatever this client 2 is inserting, you will write into that memory, and then your instance will confirm him back, okay, your data is saved. And then once later, your database instance, there's a background process called dbwriter, will take that new data, whatever written to memory, will going to write into my data files. Right. At the same time, when the data was writing here, and respective transaction log will be recorded here in the redo log buffer cache. Because any transactions happens at my database, it will be tracked. It's like a journal, that's like ledger. Whatever the transactions happens at my database side, and I'm going to keep a track of those all transactions, like change vectors or redo vectors. Your redo log buffer cache will be keep on logging those information. And if this buffer is full, your log writer background process flush this redo log buffer content to that redo log files, so that that data will be like transaction information will be permanent here. And once this buffer cache is full, your dbwriter will start writing everything into the actual data files, the physical files here. Right, again, your archive background process, we have 2 redo logs, and your log writer first initially start writing into your redo log 1, and once this redo log 1 is full, your archiver process copy that as a archive log file, arc1, and then your log writer will start writing into your redo log 2. And again, redo log 2 is full, your archiver process will copy that log file as a arc2, and then your log writer start writing into your log file 1. So it's a continuous process. Your archiver process keep on copying your redo log content as a archive log files, and your log writer keep on switching between archive redo log 1 and redo log 2. And whatever the content in the redo log buffer cache, it will be keep on writing into those redo log files. Right. So that's your overall architecture, how works. If anybody asks you in any of the interview, can you explain about database architecture? So your answer should be like flawless, like you should be seamlessly should be able to explain about database architecture, because that is the main thing for the DBA. If you understand architecture and know in and out of architecture, you can manage any database, whether it's a rack, standalone, data guard. You can easily work and you can easily manage your databases, right? So this is your any questions. This is your overall architecture, how it works, and then you should be able to answer your anyone ask about architecture. This is how you need to explain.
Yes, Malik, I have one question.
Yep.
So you said that any activity what we are doing will be tracked into redo log files, right?
Right.
So if suppose I'm inserting in wrong record, that will be tracked from some insert command that will be stored in redo log files and archived, right? So if
Right.
you want to see back that insert command, can I see that?
There is no way these all are you whatever I'm explaining, these all are binary files. As a human, we will not be able to read, we will not be able to open those files. And there are some tools, for example, whatever the read log files you have, these transactions are stored here. You want to see the transactions, Oracle will provide some tool called log miner. You have to use that log miner and see the content, what SQL command you ran, what is the transactions, all thing you can see it out. But you cannot go ahead and you cannot read, you cannot, it's just like binary files. For example, this is my read log files. And if I try to do more cat on that file, it's just like a binary file. You will not be able to understand anything. It's just like junk characters,
Oh, okay.
right? So there are some tools, you have to use those tools and read those files. For example,
Oh.
log miner is the one to read that.
Okay,
Right.
Malik, thanks.
All right. Any more questions so far on the architecture part? Right.
Yeah. Hello, Malik.
Yep.
Yeah, regarding this ASM, as you said, ASM stands for Automatic Storage Management, and which is managed by Oracle.
Right.
And if, for example, let's say, for example, system table space, in that
Right.
we'll be having some data files. If something is getting full, mean that will be also managed by Oracle, or how it works actually.
All the files, all the table space, everything will be like managed within your ASM. And here, go back. This is your data files, right? These are your data files here. Okay, your data files. In your standalone, you are having all these data files available under U01. If this U01 mount point is full, what you will do? You will ask your Linux admin to increase this U01 mount point. Right? For example, if I do df-h U01, so it is just available is 5 GB. If that 5 GB is full, I'll work with my Linux admin to increase this mount point. He will add some more 100 GB file. My database will continue to function. Similarly, in my ASM here, right? So all these files, right? Your user undo system are coming from ASM storage. If my plus data is full, what we'll do? We're going to add space to that mount point by adding some disk and all. Right? So that's how we need to manage, whether it's ASM or file system. It's a DBA job to manage that mount points. And if it's a full, we need to add the space. Right? That's where DBA comes into picture, whether it's irrespective of file system or ASM, we're going to manage those space and usage and all those things. And there's one more quick intro I would like to give about this one, right? I talked about file system. I talked about ASM. Your database may be in the file system or your database may be in the ASM. What's the difference here? So your operating system remains same. This is your lab 1 and this is your lab 2. Right? In my example, I'm talking about, I have this lab 1, right? I can go here. I have this lab 1 here. This lab 1 is file system. My database are running under file system U01. And this lab 2, my database is running under ASM. Right? That's a difference. Right, go back here. So your operating system remains same. You may have your own operating system. Lab 1 here in my case, lab 2 here in my case. And then I have ASM on my lab 2. I installed ASM on lab 2. On lab 1, I have not installed. Right? And then I have database running over here. And I have database running over here. And after that, I can connect any applications. Any application can connect to my database. Any application can connect to my database. And this database are running under that operating system lab 1, and this database running under that operating system lab 2. But what's the difference here? You have ASM here and you have file system here. And if you have local file system, that will be like OS level managed within operating system, right? That's a file system plus logical value manager. These two will be provided by OS operating system. That will be managed by my Linux admin or storage admin. Storage admin or Linux admin will manage this file system or this logical value manager, whatever we are seeing it over here, right? So whatever on this lab 1, right? Whatever this on lab 1, all the files are coming under U01. So this entire file system will be managed by our Linux admin, and we'll work with Linux admin or storage admin to increase the space or to manage this file system or anything issue with the file system. We'll work with our Linux admin or the storage admin. And whereas in case of ASM, we don't use the file system. We don't use the logical value manager. Everything will be managed by ASM. Right. So I'll go back here on this Oracle Lab 2. You can see everything is coming from plus data. So that will be like ASM what you installed. So you have to go to your ASM command line and go to that location. You have to manage DBA. We have to manage that one. So in case of file system, we work with our Linux admin or the storage admin to manage this file system and with the help of this logical value manager. But in case of ASM, your database resides under ASM. In case of file system, your database resides under file system. So in case of file system, we have to work with the Linux admin and storage admin to manage that file system. In case of ASM, we are not going to work with the Linux admin or we're not going to work with the storage admin. We as a DBA manage that file system, whatever the ASM storage, we are going to manage that one. So that's the advantages. One thing is we get rid of the dependency between my Linux admin and storage admin. As a DBA, we have to depend upon this Linux admin and storage admin to manage my database, to manage my database files. In case of ASM, we no need to rely, we no need to depend on Linux admin or storage admin. So we have access on that. We'll go to ASM CMD. You can see I connected here ASM CMD. I went inside command line. I can manage all those storage. I can manage all those file systems, right? That's one of the things. Get rid of your dependency on your Linux or storage admin. And along with that, your ASM will give so many other benefits. We'll talk on that on regular classes: mirroring, striping, high performance reads and write operations. There are so many other benefits of using ASM. So we will talk on that when we start the regular classes. So these are like advantages: your mirroring, your storage management challenges, your striping, the load balancing, your ACFS, high performance cluster read write operations. All of them are like advantages of using ASM. If you don't use ASM, so you have to depend upon your OS admin. All right. Any questions so far? Right. If no, then we'll touch base on few more concept: networking and Linux admin. So this is the last thing. We're going to cover it, few of the basics, and then we can close it for this today's demo. Networking and Linux admin is a basic fundamental things we should understand. Few of the commands I can cover it here today. First and foremost thing, you connected to your server. I'll go back here again. So this entire thing is your, let's put it over here. Right. So this entire thing, is your server, right? It may be your Oracle Lab 1 or Oracle Lab 2. Right. So it may be Oracle Lab 1 or Oracle Lab 2. That is your Linux server. And your database may be running under Linux or Windows or AX or HP AUX. Your database may be running anywhere, any of the operating system. Linux, Windows, AX, or HP operating system. Right? And then this server somewhere in your remote data center. If I can give further more illustration, we talked about 3-tier architecture, right? So this is your front end. There your end user will connect, and this is your middle tier where your application server will run. This is the back end where your database server is residing. Assuming that you have your database server here, this database server where your database instance and data files, everything will run here. And this is your Oracle Lab 1, Oracle Lab 1 or Oracle Lab 2. Right. So this entire 3-tier architecture, so it's somewhere in your remote data center. So assuming that this entire thing is in your London data center, I can say it will be in your London data center or New York or Washington DC, somewhere your remote data center. So we are in India. So how are we are going to manage these servers? As a DBA, we have to manage. I have this database instance. I have my database storage, right? So memory plus background process, which are going to talk to my actual data files here. So this entire architecture, my database architecture running under this particular servers, Oracle Lab 1 or Oracle Lab 2. And this entire setup is in my London or New York or Washington DC. So how are we are going to manage these servers? We are in India or we are in Europe or we are in Germany, wherever it is. So how are we going to managing these servers? So one thing is, if we go to the data center and we can directly go to the data center servers, we can turn it on our servers and we can access it. But it's a hard thing, right? Nobody can access to data center and we cannot work from the data center. We all work from the remote places, either like wherever remote places. Then how are we are going to manage these servers? How are we are going to manage these databases, right? Based upon where your database is running, so we're going to remotely connect to those servers. So whatever the servers, we're going to connect remotely on those servers, right? If it is a Windows, if it's a Windows server, if this server Oracle Lab 1, Oracle Lab 2, it's a Windows, we have something called RDP, remote database connection, remote connections. If you can search on your Windows, RDP, remote desktop connection, RDP. So you can give that IP address of your Windows. So you're going to get like something like this, right? Remote desktop connection. You're going to get that host name or the IP address. If it's a Windows, I'm talking about Oracle Lab 1 or Oracle Lab 2 or the IP address of that server. And then you're going to get the remote connection. Being at remote places, India or somewhere, you can access your servers. You can connect your server remotely if it's a Windows. And similarly, if it's a Linux or any Unix, AX, we have so many other tools. Like for example, Putty is a one tool, or we have MOBA, Xterm, and so many other tools. There are so many other tools. You can use those tools and you can connect to your Linux servers. For example, this is one of the things. Whatever I opened here, this is MOBA Xterm. Right? If I can go to help about MOBA Xterm, this is MOBA Xterm. With the help of MOBA Xterm, you can connect to your Linux server remotely. For example, I can take a session here, click on the session. It'll ask me SSH session. It'll ask me to enter the host name or the IP address. And whatever the servers you're running over here, Oracle Lab 1 or Oracle Lab 2, you can give the host name or the IP address for them. Right? For example, here I can give the IP address. Right? So this is my Oracle Lab 1. I can mention Oracle Lab 1 or the IP address of that one, and I can connect over here. Right? You're going to ask me to enter the username and password. So root. And then you can enter the password for that root user or Oracle user. Whatever the user access you have it, you can connect to that one. So you are connected to that server. So this is the way you can access your servers remotely. Once you access your servers remotely with the help of the tools, that's it. It's like, for example, you can either go to data center, connect to your database. or you can being at remote places, use these tools, putty or MobiXterm, access your servers. It's one and same. You got to access to your servers, and then you can do whatever administration activity you want it. Right? That's a basic understanding of how everyone will connect to servers. Like 1,000 users, 10,000 users, hundreds of users can connect to my servers remotely to manage that server, to manage their databases. Based upon what type of server it is, whether it's a Windows or Linux or AX, you can use the respective tool. Most of the Linux, AX, and or HPUX, Solaris, all those Linux flavors, RHEL and all, connected with the PuTTY or MobiXterm widely used. Your Windows servers are connected with the remote desktop connection, remote desktop protocol, RDP. So any one of the tool you can use and connect your servers remotely, and then you can manage your server. Right. Once you connect your host, you got a login access now. You are into server now, and then very first thing is your username followed by your host name. If you connected as a root, and if you connect directly with Oracle user, right? Let's go here. If I connect directly with Oracle, Oracle is a one more user inside that. And then I can provide the Oracle password. Again, I'll be into same Oracle lab one remotely, but this time it is a Oracle user here. Oracle user and the host name. And this time here is the root user and the host name. So whichever user login, that username will comes here. And the interesting thing is, can I necessarily take multiple sessions for the different users? If you want, you can take like one session I took for Oracle root user here, and one session I took for Oracle user here. So if I want to connect 5 users, can I take 5 sessions? Yeah, you can take 5 sessions, no use in that. But is there any way I connected to root user here? Can I go to Oracle user within this session itself? We have something called SU. SU stands for switch user. Switch user to which user you want to connect. Right now I'm in root. I want to connect to Oracle. Right now I'm into Oracle. So from Oracle, can I connect to root? Again, switch user, root. So it will ask for the password. Right. So now I'm into root. So this switch user stands for switch user from one user to other user. And interesting factor here is root is a master user in Linux. Root is a master user. He can connect to any user without password. For example, I was here root. I did a SU Oracle, automatically connected to Oracle user. It did not ask for the password. And from that Oracle user, you're trying to switch to root, it'll ask for the password. You have to enter that root user password, then only it's going to go to root. Because root is a master user. From the root, you can connect to any user. But from the normal user, if you want to connect to any other user, you have to enter the password. Right? That's one thing. You can switch between one user to other user anytime. And the second thing is, we know this is my host name. If I do host name, I can get my host name. And I want to get, this is the IP address. I want to get the IP address assigned for this host name. Host name -I. Just give this -I. They're going to get IP address assigned to for this host name. Right? And then what are the IP addresses are available on this particular host name? I can type this ifconfig. Ifconfig is to list the IP address available on in this particular host. What are the interfaces available on this host? Right? So I have interface one IP address assigned over here. I have interface 2 for this host, but there are no IP address for that. Right? By looking at this interfaces here, it may be ETH0, ETH1. By just typing this ifconfig, you can see whether the IP address is assigned or not. Right? That's how you can validate. And the other thing is, we talked about root user, we talked about this Oracle user, where I can see all these users. There's something called cat/etc passwd. The moment you check your cat etc passwd, and all the users, Malik 1, Malik 2, Satish, Varadev, Oracle, Malik, all these are the users. We can list it out in my server, how many users are got created. Remaining all these are like service account. It comes default with your Linux installation, right? But whatever this after the TCP dump, whatever you're seeing, these are your service accounts. So right now I can see Malik 1, Malik 2. I'm going to add one more user, Malik 3, user add Malik 3, right? That's the third user, right? So user added. If I cat the same file again, cat etc passwd, and you can see Malik 3 here. I can connect to switch user to Malik 3. It will go to Malik 3 user, right? So that's how we validate whether that user is available or not. Like for example, if I trying to log in with Malik 4, it says Malik 4 does not exist. So this is how like you can validate your IP addresses, you can validate your host names, and you can validate whether your Google working or not. For example, you do simply ping google.com and whether the internet is working or not in your server. So you can just do all this like ping google.com, whether you have internet connection or not. Right. So these are like few things like, whether the user is exist or not, and what are the users. And then if Malik want to connect, or like, if your password maybe get expired, so you can reset the password using passwd. Passwd is to reset the password. For Malik 3, I'm gonna reset the password. So Malik 3, what's the new password? I'm gonna set the password for him. Right? So Malik 3 password set now. So Malik 3 can directly, this is a new user, Malik 3 joined my organization as a DBA. Your Linux admin will create that Malik 3 user ID and password. He will give it to him. And then I can directly log in with my ID. I'll go here and then I can directly connect with Malik 3. Malik 3, and then I can enter the password, whatever that Linux admin has given it to me. Right? So I connected to my ID now here, Malik 3. And then I can quickly check it out. What are databases are running on this server? Right. So I can see DevDB is running. Okay, then Oracle username and password will be aware of that. All the DBAs will be aware of Oracle username and password. So I will initially connect with my user ID, and later I'm going to switch to Oracle user, because your database is running with Oracle user. You have to run this ps-f grep smon, and your database is running or not, you will get to know here, and with which user is it installed, Oracle user. So I'm going to use su switch user Oracle. So I'm going to enter the Oracle user password. Right. So now I'm into Oracle user. So and then I can set the environment to my DevDB database, and I can connect to my database. Right. So that's how in industry works. So anyone joins a DBA organization, and then he will be created with his own user ID and password by your Linux admin. We will first connect to that particular whatever my user ID and password. After that, I'm going to validate which database we're running and which Oracle, which owner of that database. DevDB is the database owned by Oracle. I'm going to do su Oracle. From once I log into Oracle, I can connect to my database and I can manage my database, whatever I want it. Right. So that's a simple understanding how, where are your servers, how you are going to access those servers, and then you will be having your own ID. With that own ID, you will be logging to that respective Oracle owner, and with that owner, you're going to connect to your database and you're going to manage your databases. Right? That's a typical way how each and every industry works. Nobody will get direct root access. If you see here, I connected directly with the root access. So nobody will get a root access to Linux servers in industry, because Linux root access will be owned by your Linux admin. So as a DBA, we will be having our own user ID and password, or we will be having a Oracle username and Oracle password. So we'll connect with the Oracle directly, Oracle username and password, or we will connect with our own Malik username. And later I'm going to switch to Oracle user and I can connect to my database and then I can manage it. Right. So that's a typical way of how it works. Any questions so far? All right. So we are going to stop it for today now, because if I start explaining further more things, things gonna go complicated, and then everything will bounce, I can say, who are like new to this DBA field. I'll stop it for now, and then any questions anyone has, feel free to ask. Anything related to whatever topic we covered today or yesterday, or anything related to this course, questions or queries, you can always ask here.
Hello, Malik.
Yep.
Yeah, Malik, will you cover the data guard on core or rack environment?
In the rack.
In rack on data guard.
No, rack will not be covered. It's a standalone, right?
No,
And again,
data guard topic. Will you
data
cover
guard
in
data guard will be part of your database course, right? If you observe, like if you attend my yesterday's session, if you go to this training here, and then if you come to chapter number here, where is that one here? Chapter number 18, I already explained yesterday. We'll start from the scratch. We'll understand production, standby database. We're going to build standby database from the scratch. And then we're going to do this log shipping, how we can monitor it. And if your DR is out of sync, how you can make it sync. And your data guard switchover, failover, DR drill activities, all those things will be covered as part of this chapter number 18.
will you cover this data guard broker topic on this data
No.
guard?
No, we'll not be covered that data guard broker. All right. So any questions, guys, before we stop it for today?
Malik, what is the difference between SU and pseudo SU?
Okay. Again, that is too early to explain, but let's go here. What your Linux admin will do, you connected to Oracle Malik user here. I connected to Malik user here on Oracle Lab 2. SU Oracle, if I do, I have to enter Oracle user password. Right? That's a mandatory. If you just do SU and whatever user you are going to log in, that user password you need to enter if you just do SU. And instead of that, if you use sudo su Oracle, it will not ask for that Oracle user password. Directly it's going to connect to your Oracle user. Right? That's a sudo that your Linux admin will set up. For this Malik 3 user, he will set up sudo su and he can directly connect without Oracle password. I can simply do one setup here. There's something called /etc sudo or file. And then in that sudo or file, you're going to add, for example, I'm going to add Malik 3 user for this Malik 3 user. I'm going to set it everything. The Linux admin will set all of them. Right. So the moment you set it here, now cancel this one here. Right. So when I did here SU Oracle, it'll ask for the password here. Right. And now I'll exit. I'll do sudo su Oracle user. Right. Just exit one time. And now you can connect sudo su. Sudo su Oracle without password, you're able to connect now. Again, exit. Right now you are Malik 3 and you can use sudo su Oracle. And then without Oracle password, you can directly connect to Oracle user. That is the meaning of sudo SU Oracle or just SU Oracle. Just SU Oracle, you have to enter the Oracle user password. Sudo su without Oracle password, you can connect to Oracle user, provided your Malik 3 user need to be added to your sudo file that Linux admin will add. In this Linux admin Malik 3 user, you need to add some permissions and grant, and then you can use this sudo su without Oracle user, you can connect to Oracle user. All right. So any more questions, guys, before we stop it for this today's demo?
Malik, do we
yeah.
have ASM topic in the paid session?
Do you have what?
ASM topic.
Again, yesterday we talked about, right? It will be part of your course.
Okay.
If you go here, chapter number 9, we're going to talk about ASM architecture. We're going to talk about installation of your ASM, and on top of we're going to create the database, and then we're going to understand management of my ASM, administration of ASM, my disk group management. All those things will be covered here.
Okay. Okay. Thank you.
All right. Any more questions, guys?
And we also come across a word called TSM. What it is? And
TSM is your third party backup and recovery storage. We have TSM, Net Backup, Veritas, Rubrik. There are so many third party backup and recovery solutions. So
Okay.
either you can manually do this RMAN backup, restore, recovery on your own local storage, or you can buy those third party tools and you can manage your database backups and recoveries using those tools.
Malik?
Yeah.
As you told in that Dev 1 and Dev 2, the connectivity between mobile extreme and putty and all, if you are in Europe or in Asia and African countries or American countries, you told you will be connecting through putty or like mobile extreme or RCP, as you told. Okay. See, for example, we today's environment, because wherever we see is OCA, Oracle Cloud Infrastructure, which you are very much aware. So if basic knowledge, as a layman, we are asking, see, you are connecting to the remote, the servers will be standby, will be in North America, Europe, Asia and all. You are connecting through whatever you told, like RCP, for example, putty, mobile extreme, XYZ. But what is the difference between cloud and this remote connectivity? See, the cloud, you don't know the exact location where the servers are set up.
It doesn't matter whether your servers on cloud or whether your servers on data center, and you're going to connect using the same method, RDP or Windows or putty or mobile extreme.
So yeah, you have given a nice example for that. So what is the difference between cloud and this remote, which your data center setup? So
cloud, simple understanding. In order to keep these servers in your own data center, you should have your data center. You should have that maintenance cost. You have to manage.
Malik, I don't want to disturb you that maintenance cost and everything. Because of that only we are going for cloud. No, in industries, whatever they are asking, if you go for you are very much aware than us. All the companies are now focusing on cloud. You have experience in the cloud. What is that experience of cloud? Because whatever we are doing in the data center or in our client setup, we are sitting and we're connecting to the data center, we are doing the XYZ activities. But what is the difference in cloud? See, what is
you forgot about everything. Why cloud? Why your own data center? Are you willing to manage your own data center? Are you going to keep your thousands of servers into your own data center? If yes, go ahead and do for that one. If you don't want to manage your data center, if you don't want to keep hundreds of thousands of servers into your data center, go for cloud. Simple understanding.
Yes, I got it. One more small doubt. So what is the connectivity difference between?
No difference, nothing. It's all same. You're going to use same RDP. You're going to use putty, whether your databases are or whether servers are in your own data center, whether your servers are in your cloud. We're going to use the same RDP, same putty, same mobile extreme. No difference at all.
So there is no high-end activities which you are going to perform. So same thing what you're going to, but the name what is the, instead of remote, it is a cloud. That's it.
Right.
Yes. Okay. Thanks for that.
Yep. All right. Any more questions, guys, before we stop it for today?
One more thing is I missed 1 hour class of yours today's demo class.
I'm going to share the recordings. You can watch through that.
Where you'll be sharing in the WhatsApp group.
Yeah.
Yeah. Once let me complete that, and I will talk to you in one-on-one.
Right. Yeah.
Thank you.
All right, guys. Any last questions before we stop it for today?
And one more request from my side, Mr. Malik. See, you are known very much that today's competitive world is very much high. And also one of our, I think so, I forgot the one of our colleague who requested about you whether you're going to include this data broker and all. Can you give us the outline of the data broker so that you can't set up in your environment, because that means a learning environment. Can you give a picture about
that
the
again,
data
as I told clearly, it's not only one topic we're going to come up. Once we start the course, there's like hundreds of topics people will be requesting for that. You know, we
Please.
cannot cover everything. We're going to go for majority of the vote who are interested on which topic. At the end of the course, we can include one or two. For example, your wallet, your TDE, your data card broker, your OEM, and your some of the basics of rack. So there will be hundreds of topics each and every student will be keep on requesting. So we cannot cover everything as part of this course. Whatever I form this course based upon my experience, whatever needed for day-to-day activities, right? So this is everything covers over here. Apart from this, whatever the planned, any extra topics that is subjected to end of the course and the timeline and how many people, how many students are interested. Otherwise, you know, will not be covered any extra topic apart from this.
Okay, it depends upon the majority people's request you. That's it. Okay.
Right.
Okay, thank you.
All right. Let's stop it here for today. We'll see you on Monday with the regular classes, guys. Right. Thank you all.
Thank you, Malik.
Yeah.
Thank
Thank
you,
you
Malik.
all. Bye.
Thanks, Malik.